Let's look at equations involving addition. Remember that an equation is like a balanced scale. For example, if you saw 5 equals 5, right? That would be obvious, but this is actually an equation. You can think of this equation like a balanced scale, okay, where each side had, say, 5 marbles. 1, 2, 3. Okay, there you go. And the other side would have 5 as well. 1, 2, 3, 4, 5. So now ask yourself, what would happen if we added 1 over here? Plus 1. Well, now this would not be equal anymore, right? If we had 6 marbles, 1, 2, 3, 4, 5, 6, 6 marbles on here on the left and just 5 marbles on the right, this would no longer be equal unless we also added 1 to the right side. Now, this would once again be an equation. 5 plus 1 is 5 plus 1. What if I undid this? Okay, so now I subtract 1. Okay, so if I subtracted 1 from the right side, that would be like taking this away, right? So instead of adding 1, let me take 1 away, minus 1. So if I click undo. Now, once again, if we had 6 marbles here and I took 1 away, this would also not work. This would not be equal anymore unless I also took 1 from the left away. Boom. And now it's equal again. Okay, so remember this equation, or any equation, you can think of it like a balanced scale. We can do anything we want if we do it to both sides. Okay, and when you get to high school level math, there are actually a few exceptions for equations, but for middle school math, you can think of it as you can do anything you want if you do it to both sides of the equation. All right? So let's look at some sample problems. Okay. Let's say x plus 3 equals 5. And we've talked about this before, but to solve an equation, we need to find out what number is our variable. What is x? Okay. So if you think of this as a balanced scale, we could again draw a scale. So the left side would be x plus 3 balanced with the 5 on the right. Now, if you're looking at this equation, this happens to be a really easy one, you could kind of just see, well, what plus 3 equals 5? The answer would be 2. But here is how you would solve for x systematically, because you're not always going to see equations this easy. Okay, so here's the procedure. If you have a variable plus a number equal to another number, to solve for the variable, you want to do the inverse operation. Okay, you want to do the inverse operation of addition. Now, what is the inverse of addition? The inverse of addition is subtraction. So instead of plus 3, we want to subtract 3 from both sides. That is very important, from both sides. Okay, once we do that, it's going to be pretty easy. X plus 3 minus 3. This is a 0. It cancels each other out. That's the point of an inverse operation. inverse operations undo each other. They cancel each other out. So plus 3 minus 2, that's a 0. So we have x, right, 0. X equals 5 minus 3, which is 2. Right, this right here is a plus 0 if you wanted to do that, but plus 0 is nothing, right? X equals 2. All right, let's do a lot more of these. How about x plus 7 equals 18. Again, we want to solve for x. So let's do the inverse of addition, which is subtraction. Let's minus 7 from both sides. Plus 7 minus 7, that's a 0. Cancels out. 18 minus 7 is 11. X equals 11. All right, what about y plus 3.5 equals 10? We want to solve for y. Let's subtract 3.5 from both sides. Okay, this right here cancels out. 10 minus 3 is 7. 7 minus the 0.5 is 6.5. And remember, for equations, you can always check if your answer is correct by substituting this number in to our original equation. So we started with y plus 3.5 equals 10. This is what we started with. So to check if this is correct, let's substitute 6.5 for y. If we did that, 6.5 plus 3.5. 6.5 plus 3.5 indeed is 10. It works, so our answer is correct. Okay, let's keep going. Let's keep going here. How about x plus 4.5 equals 6? Well, let's subtract 4.5 from both sides. 4.5 minus 4.5 cancels out. X equals, what is 6 minus 4.5? That would be 1.5. And again, if we wanted to check, if we plug in, we started with x plus 4.5 equals 6. Plug in 1.5 for x. Is 1.5 plus 4.5 6? Yes, indeed it is. This is correct. All right. How about a word problem now? Abe had $22.25. His mom gave him some money. And he then had $38. How much did he get from his mom? All right, so we previously talked about translating English into math and vice versa. So with this word problem, you're going to need to set this up in math. Okay, here's English. This paragraph is English. Let's turn this into math and solve. So, $22.25, that is a concrete, specific piece of information. So this number right here, that's simply going to be itself, 22.25. Okay, so that's one specific info they give us. Abe had $22.25. His mom gave him some money. So that's what we need to figure out. How much did Abe get from his mom? So this is our mystery number, some money. And anytime we have a mystery number, that's what we want to set our variable to. So we can say 22.25, that's what we started, plus, now you could say x, you could say n, that all works. For me, how about, since we're talking about money, I'm going to say m. Okay, that's our variable. The money that Abe got from his mom, that's m. After his mom gave him money, he then had $38. How much did Abe get from his mom? How much is m? What is m? That's what we want to solve. So this whole paragraph, once you interpret it correctly, once you set it up as a math equation, it's very, very simple. We've been doing this whole video. Now remember the commutative property, 22.25 plus m, that is the same as m plus 22.25. Okay, so commutative property. I'm just going to switch these, right? Switch. And then to solve for m, we just need to subtract 22.25 from both sides. Okay, so minus 22.25 minus 22.25. Over here it cancels out. M equals, now what's this part? 38 minus 22, that would be 16. That would be $16. And then $16 minus 25 would be $15.75. So m equals 15.75. How much did Abe get from his mom? Abe got $15.75 from his mom. This is your answer right here. Okay? Don't leave it as this, because this doesn't have the unit. Like, what is this? This is dollars and cents. So this is your answer right here. Okay, and let's do one last problem, and then we'll be done. What number added to 43.7 is 70? What number added to 43.7 is 70? What number? How do we represent this part right here in math? What number, mystery number, some number, that's our variable. I'm going to say x. Okay, that's what number. What number added to? So that's added plus added to 43.7 is, we talked about this, is means equal in math. Okay, here's the English above, here's the math, 43.7 plus x equals 70. Remember, commutative property, we could switch this around, right? X plus 43.7, switch them. The important thing is, to solve for x, let's subtract 43.7 from both sides. X equals 70 minus 43.7. Okay, 70 is the same as 70.0 minus 43.7. Subtract. borrow from here. 10 minus 7 is 3. This becomes a 9. 9 minus 3 is 6. Borrowing, this becomes 6. 6 minus 4 is 2. X equals 26.3. And this is your answer. What number added to 43.7 is 70, 26.3. So remember, today we focused exclusively on equations involving addition. It was always a variable plus something, or something plus a variable. And to solve addition equations, you need to do the inverse of addition, which is subtraction. All right, and in the future, we're going to look at subtraction equations where the inverse would be addition. That's it for today.